Convert standard notation to scientific notation. So the scientific notation format is a number times 10, and then it's raised to an exponent. This exponent can be positive or negative. Now, when looking at establishing the first number, when we convert into scientific notation, we're going to go ahead and move the decimal so that only one number is to the left of the decimal. An example of this would be like 4.09. Then to determine the exponent, what we do is we count the number of times that the decimal is moved. And then when we're deciding on the integer, determining the integer, if the decimal moved to the left, the exponent is then positive. And if we move the decimal to the right, the exponent is negative. This is the opposite than with converting to standard notation. So let's look at an example. Example 1. Convert 0.0625, which the fraction 1/16 is as a decimal, to scientific notation. So we need to have a number and only one to the left of the decimal. So that means we're going to go ahead and need to move this decimal. And when we move this decimal, we're moving it to the right, as these are just zeros. So we move it 1, 2, and we end right there. So now we have 6.25. Then we know we have to go times 10 to the raised to a certain number. Now we moved it to the right, so that means our number is going to be negative, and we moved it over 2 times. So we went 1, 2. So this is negative 2, and this would be our final answer. So let's do another example. Example 2. A project requires 2,400 pounds of steel. Convert 2,400 to scientific notation. So here we have 2,400, which the decimal is right there. Now we need to go ahead and move the decimal over to the left. So only one number is to the left of the decimal between the numbers of 1 to 9. So then we go ahead and move this decimal here, here, to here finally. So this new number is 2.4. The next two are zeros, so we can just leave them and not include them as 2.4 or 2.400 is the same. So we have 2.4 times 10, and then it's raised to the third power, because what happened was we moved over 1, 2, 3. So we moved over 3 and we moved to the left. So that means it's going to be positive 3. So this would be our final solution. Let's do another example. Example 3, convert 467 to scientific notation. So we have the number 467. We have a decimal here. Now we need to move this decimal over, and we move it over, we'll see, 1, 2. So we want to end there. So it's 4.67. So now we only have one number to the left of the decimal. Then we go times 10, and we notice we moved the decimal over 2, and we moved it to the left. So this makes our exponent positive 2. So this would be our final solution. Now let's do a final example. Example 4, convert 0.037814 to scientific notation. So when we have this number, we need to go ahead and move the decimal now to the right. This is because the first digit that's between 1 to 9 is on the right, as the other ones are just 0. So we would move over 1, 2, and we would stop there. So we have 3.7814 times 10 to the, well, we moved it over to the right, so that means we're going to have a negative exponent, and we only moved it over 2. So this would be our final solution.